What if I asked you this right now? Quick, tell me the square root of 81 without a calculator and in 5 seconds. You'd probably laugh and say, I don't even need 5 seconds. It's 9. Easy, right? But now, let me ask you this. What's the square root of 87? Suddenly, it's not so straightforward. It's not a perfect square, so you might guess, um, something around 9 point something? And that's where most people get stuck. But don't worry. Today, I'll teach you a powerful trick that lets you estimate square roots lightning fast, even for numbers that aren't perfect squares. Just one thing. There are a few spots where you'll want to be careful. I'll show you those at the end. Let's start with the square root of 87. Step 1. Write down the squares of numbers from 1 to 10. 1 squared is 1, 2 squared is 4, 3 is 9, 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81, and 10 is 180. 100. Now look for the perfect square just below 87. That's 81, and the square root of 81 is 9. So we know. Check mark. The square root of 87 is 9 plus a fraction. Now here's the trick for the fraction. Take the number you're estimating, in this case 87, subtract the square just below it, 81. That gives you 6. Write that in the numerator. Take the base root, 9, and double it. That's 18. Put that in the denominator. Now you've got 6 over 18, which is 1/3, or about 0.33. Final answer, 9.33. The real square root of 87 is about 9.327, super close, and much faster than punching it into a calculator. Let's try square root of 39. The closest perfect square below 39 is 36, and the square root of 36 is 6. So our estimate is 6 plus a fraction. Subtract 36 from 39, that's 3 double the base root, which is 6, that's 12. So we get 3 over 12, or 1/4, which is 0.25. Final answer, 6.25. The actual square root of 39? 6.245 again, super accurate, super fast. Try one more. Square root of 69. Perfect square just under 69 is 64, square root is 8. Now 69 minus 64 equals 5. Double 8 to get 16. So 5 over 16, which is roughly 0.31. Final estimate, 8.31. Actual value, 8.307. Nailed it again. Quick test, square root of 27. Closest square below is 25, and the square root is 527 minus 25 is 2. Double 5 is 10. So 2 over 10 equals 0.2. Final answer, 5.2. Actual square root of 27? 5.196. So once again, very close. But hold on, there's a catch. This method is awesome, but let me show you where you have to be careful. Let's estimate the square root of 2 using the same trick. Closest square below is 1, and the root is 1/2. Minus 1 is 1. Double 1 is 172. 2, so 1 over 2, which gives us 1.5. But the real square root of 2 is 1.414. So we're off by a bit. Here's how to fix it. Take your estimate, which is 1.5, and square it. That gives you 2.25. Now do 2 minus 2.25 equals negative 0.25. Divide that by 2 times 1.5, which is 3. So negative 0.25 over 3 equals negative 1/12. Now subtract that from 1.5. 1.5 minus 1/12 equals 1.4. 1/7. Much closer to the real value. And you can repeat this process again to get even more accurate. Bonus fact. This trick is ancient. This method actually comes from the Babylonians, one of the world's earliest civilization line in what's now Iraq. It was later refined and formalized by Sir Isaac Newton in the 1600s. As part of his Newton-Raphson method, an iterative process used in calculus to find roots of equations. We won't go into all that math here, why, but it's cool to know you're using a method that's both ancient and mathematically sound. If this video hits 20,000 likes, I'll make another amazing math trick video that will totally blow your mind. If you're enjoying these and want to support what I do, consider becoming a Patreon. The link's in the description. Or join our community and become a channel member. It helps me create even more awesome content for you. Thanks for watching, and I'll see you in the next one.